Thanks, Esther, and welcome everyone to today's webinar on innovative technologies. This is a webinar in our series featuring Energy Star Partner of the Year award winners. And so today we have two speakers. Dan Egan is a Senior VP of Energy and Sustainability from Vornado, and Randy Moss is a consultant at Yardi, and both of them will be talking about different technologies that they have implemented at their companies and sharing some case studies of how they've achieved some energy savings. So I will turn it over to Dan to start today's presentation.
Great, thank you very much for the introduction, and hello to everybody out there. I hope everyone is doing well during this strange time here. So my name is Dan Egan. I'm Senior VP over at Vornado. I'm going to give a brief overview of Vornado. We are a publicly traded real estate investment trust with about 25 million square feet of office and retail buildings, primarily in New York City. We do also own the Merchandise Mart building in Chicago and 555 California Street complex in San Francisco. To give you a sense of scale, because sometimes square footage doesn't quite always convey scale, we do consume about 280,000 megawatt hours of electricity a year. We recover about 60% of that from our tenants through submeters. We are a very large district steam customer here in New York City, as well as in Chicago and San Francisco. And we have a sizable consumption in water and smaller consumption in natural gas and oil. But our group here at Vornado manages the consumption profiles and related costs for the utilities across the company. Of note, going into this, we have a very robust sustainability program that's been in place for over 10 years. We're very proud with our most recent announcement of committing our buildings to carbon neutrality by 2030 through what we're calling a Vision 2030 roadmap. I wanted to highlight here that our top priority with decarbonization is, in fact, energy efficiency. We do believe the most valuable and impactful part of decarbonization is to do it with less energy to begin with and doing more with using less. So to stand behind that carbon neutrality commitment, we have a 50% energy efficiency goal on our consumption by 2030, and that's below a 2009 base year. So as of 2019, we are proud to say we're at 24%, or just about halfway there, with a 10-year plan put in place to get us the rest of the way there. In addition to energy efficiency, optimization of demand is worth mentioning here in the context of this program, in that we believe that it's very important to not only consume less energy, but to understand the right times of day, week, month, or year to consume energy in ways that are both cost-saving as well as carbon-saving, and I'll get into that a little bit in a minute. So we also understand, as a commercial office landlord, we understand that energy efficiency must be a partnership with our tenants. As the landlord, we really control a minority share of the energy going, being consumed in our buildings. And so we've bifurcated that overall efficiency goal into one for both the landlord, which is us, as well as our thousands of tenants across our portfolio. And so we track progress separately, and that gives us two different sets of motivations and two different strategies. One is on the landlord side in terms of capital projects that we can deploy, our own employee workforce to make sure that best practices are part of our operations program, and all the core and shell sort of work that goes around creating an efficiently run building with efficiently run mechanicals and envelope and so forth. The tenants do control, obviously, a substantial lighting and plug load and supplemental HVAC load profile. And so part of what our program is meaningful stakeholder engagement with our tenants, as well as lease-driven provisions to make sure that we are tackling energy efficiency both from the tenant perspective as well as the more hands-on project-oriented perspective on the landlord side. And so thinking about that, I do think that data is really the driver behind doing energy efficiency correctly. I put this graphic up here. This is 512 West 22nd Street, which Vornado completed a couple of years ago here in New York City. And this is an attempt to illustrate just the many different ways we need to understand energy, because that gives us a greater understanding of cost as well as carbon. And it also helps us target where the energy is being consumed, when, and by whom. So I've highlighted, a couple of different lenses that we view our buildings. The first of which is the whole building, which I would say is the conventional lens. Most of our buildings have 1 or 2 utility bills that we can use as a sort of one-dimensional snapshot value to understand where we stand on a per square foot basis. 90-something% of our tenants are sub-metered in our portfolio, and so we have visibility into the tenant's consumption individually, so we can understand when are our tenants consuming energy. Is there any trends that we can identify with tenants that represent particular industries that are of a certain size, whose spaces are of a certain age, and that gives us a lot of insights into how and why certain tenants behave in different ways across our portfolio. From there, we can either directly meter or by process of elimination understand what the landlord and base building consumption is. So when you have a building where all of your tenants are sub-metered, sort of the unmetered portion represents the landlord component. And that gives us a lot of insights into just what we can control and the progress that we're making on the energy that we can control in terms of reduction. And then I'd say more recently, our regulatory environment, particularly here in New York City, has caused us to look outside of the 4 walls of our building and understand the carbon components and the pricing components of the energy as it enters our building from the utility. So here in New York City and New York State, I'll mention the Climate Leadership and Community Protection Act, which is a host of climate-related regulation, but mandates that by 2040, the electricity in New York State must be 100% carbon-free. So that gives building owners quite an incentive to pay close attention to the progress towards that mandate, because that helps us understand over time how we're supposed to think about energy, how we're supposed to consider electricity versus other sources of energy, such as district steam, natural gas, and oil, and how that translates to a decarbonization strategy, particularly when you have ambitions of becoming carbon neutral in 10 years. So this is a whole new and complex ecosystem of energy and the various ways that we can collect data to understand what's happening in our buildings. I will also do a plug here for the newly created Energy Star Tenant Space Program, which has given us a lot of tools to motivate our tenants, not just to track the drivers behind their own energy consumption and opportunities for efficiency, but gives recognition opportunities to tenants so we can sort of reward them with best practices and understand, which tenants are truly leaders in this space across our portfolio. And so knowing all of this, I think that when it comes to evaluating energy efficiency, we need to depart from the more conventional simple payback analysis because there's so many more drivers behind the value of energy efficiency. Here in New York City, for example, that will come in the form, we need to add to the value stack the avoidance of penalties. So I'll mention the Climate Mobilization Act, which is a host of city-level regulations, the most stringent of which is Local Law 97, which will assess penalties starting in 2025 to buildings that exceed a carbon emissions cap. That actually, that has a straight relationship between financial risk and carbon risk. And so we need to pay close attention to the greening of the grid to understand when we're planning for energy efficiency, not only are we going to be saving energy costs, but are we avoiding penalties as well? And that sort of enriches the value stack and builds the business case to move forward with a lot of projects that maybe historically or conventionally weren't delivering paybacks that got decision makers particularly excited. So in addition to that, demand savings should be added benefits. depending on the availability of time of use markets and demand response markets. So many times our energy efficiency projects are associated with automation, which can deliver curtailment revenue or demand savings that should also be part of the equation. And so let me move forward here. But the long story short, we have a much more enriched way of measuring the value of energy efficiency. So I know we were here to hear about induction unit valves. So this gives you a brief description of what this project was. We worked with a very talented and wonderful firm called Goldman Copeland, an engineering firm located here in New York City. We took a look at 4 of our buildings across our portfolio to understand, are the perimeter systems that are in these office buildings operating as efficiently as they can? Historically, these systems were using a lot of outside air, which can lead to overheating and overcooling our perimeter HVAC system. With something that's very simple, a valve control, we are actually able to modulate the amount of outside air so it's actually matching what the desired temperature need is. In buildings at our scale, many of our buildings are well over 1 million square feet. This can lead to thousands of these valves controls being put in our perimeter systems and can also lead to thousands of dollars in annual savings, as well as the related GHG emissions reduction. I will pause here and just say that, more recently we're looking very critically at the availability of outside air in our buildings, as it's been recommended by various agencies to be best practice in the age of COVID protection. So if folks are looking for energy efficiency projects that mitigate delivery of outside air, it's always going to be a balance to make sure that you're also providing fresh air quality and IAQ that's meeting the needs of your various stakeholders. So I want to also just take another case study here with the BMS upgrade that we have in the works here in one of our larger buildings. The BMS upgrade project actually yields not only significant energy savings, but also DR revenue, which comes in the form of payments that we can reasonably expect to receive here in New York City from both Con Edison as well as the New York Independent System Operator. That goes into the value stack when considering this project. But also I wanted to sort of just add here, what you can see in the gray bars is not only are we seeing the savings more conventionally from energy, but we also have fine avoidance thanks to Local Law 97 and projected penalties for the building. And what you see is that you are shortening your payback period and adding quite a bit to your annual value stream. So what we probably, to be honest, our company would have elected to do the BMS upgrade either way. But for those on this attending this webinar, this is just an example of an additional way to evaluate these energy projects that might put something over into the green light column, whereas prior to this, it might not have been delivering exciting returns. Okay, and then here's just another example. So we have a chiller plant that needs to be upgraded. In fact, it needs to be replaced. This is interesting because we right now have a steam absorber using district steam here in New York City. District steam is, as everyone knows, not electricity. And so the future of steam in terms of the carbon emissions is in flux. And to remain on district steam, we need to really consider how this stacks the building up against future regulatory requirements. And so by transitioning over to an electric chiller, which is what we're planning to do, we not only are going to have some energy savings, which comes along with replacing an absorber that's at the end of its useful life with a brand new latest technology machine, but in addition to that, we're going to project some carbon emission savings, which has a direct value in terms of avoided penalties. And so what you see is, again, the enriched value stack. What's interesting here, and I admit that this is not going to be part of everyone's value stack, and even for us, it's a rare instance, but interesting enough to put in the presentation. the existing chiller is on the first floor of one of our office buildings in a space that arguably could be rented to a tenant. By relocating the chiller down into the basement where we happen to have lots of room, we put ourselves in a position where we could realize additional revenue just by moving this. And so we convey the value of this project using any combination of the above. But it's also, I think, not only is this important when delivering the value of energy efficiency, but it also makes it resonate with a wider audience. So when you are able to realize benefits that are not only energy related or carbon related, but they actually can deliver revenue, you take advantage of an opportunity to convey this to whether it's your leasing, your capital markets, or your executive team. It makes for an easier conversation, or certainly a more interesting one that piques the interest of our decision makers. So just as takeaways here, oftentimes, I know that this webinar is for innovative technologies, and there are plenty of them to be deployed. Sometimes it's actually a tried and true solution that has automation and is informed by good data to support their value. So I don't think we should leave out conventional energy efficiency solutions when we're talking about innovative technologies. Sometimes it's really a matter of applying their value more creatively and making use of the new streams of data that are available. You must understand energy data at different points of the supply chain. When I mentioned the source energy of our electricity grid as an example, that will help you understand the value streams to add to the stack. Energy efficiency and GHG emissions, they're often correlated, but rarely linearly or perfectly. And regulation and market signals will continue to drive efficiency. New York City is one example, but I have a lot of confidence it's coming to other parts of the country. And so with that, I will go ahead and pass the ball to my colleague, Randy. Thank you.
Thank you, Dan. Appreciate that. Hello, everybody. My name is Randy Moss. I am with Yardi Energy, work out of Yardi's local Atlanta office in Atlanta, Georgia. And I want to talk to you a little bit today. I'm sure many people on the call are familiar with Yardi. I want to give a brief overview before and then lead into looking at both the tried and true methods Dan has mentioned, the importance of data, and then show some true AI technology that Yardi has available and we're using with clients, and we'll show you 3 specific case studies. So, and our good host is Energy Star said I have 20 minutes to talk through all this, so bear with me. Look forward to questions and answers afterwards. So Yardi at its core is a software company. We provide an integrated ERP solution for customers in the commercial real estate industry. This is for managing commercial real estate and to help building owners and building managers be more efficient in many areas. One of those areas that we work in is, of course, Energy Star. We were able to earn Energy Star Partner of the Year the last 2 years and continue to keep that string alive, hopefully going into the future. As a service provider, we are collecting that important source data at the appropriate granular level and feeding that to Energy Star after it has been audited and confirmed accurate. During that process, Yardi does other things with the data, and that leads us into the discussion on the way Yardi operates. Yardi's core product, where building owners can manage buildings and run their full ERP solution, is Voyager. And as people have the core Voyager, an easy add-on is a procure-to-pay product we're not going to really discuss today, and Pulse, which is our energy efficiency suite of products, and that's where I'm going to discuss. I do need to mention procure-to-pay on the way by because it is very important on this slide. What you're seeing here is the result of studies done over time analyzing costs for commercial real estate. The largest cost, of course, is maintenance, repairs, and operations, but close behind that is utilities. Think energy and water. And as Dan pointed out, now there are new things coming in to be considered, such as Local Law 97 in New York. Dan, I'll mention, as you hinted at in your summary, other jurisdictions across North America we know are watching New York very closely in anticipation of rolling out similar laws in other states and in other cities. So anyway, MRO is always the biggest group of expenses, but surprisingly, utilities comes very close behind that as your second largest controllable cost for commercial buildings. So getting a handle on those utility costs and ultimately driving in new solutions is what we're going to dig in a little deeper. Dan mentioned data several times, and I cannot stress heavily enough the importance of good granular data in making decisions to control utility efficiency. Yardi does this for our clients with a basic pulse invoice processing where the data is collected from those invoices as they flow into the Voyager ERP system. My group that manages benchmarking for our customers comes into play by extracting that quality data that's been audited to feed for Energy Star, GRESB, other types of ESG or sustainability programs where reporting is required. We're able to manage those benchmarks going forward. Utility data, as it is loaded to Energy Star or as you view it in reports, gives you a very good lens into what happened. This is always past tense because utilities will send their bill after they read the meter. You get that a few days after last month's history. So again, a good lens into what did happen, but it doesn't tell you what's happening today. The Meter Insights, which is taking your data to the next level of monitoring meters real time. You can do this for your sub-meters. As Dan mentioned, Vornado is doing in some of their buildings with sub-metering, knowing tenant spaces. Or there are other means of even tapping directly to utility meters for the building if you have single tenant buildings to know exactly what's going on in your buildings at any given time. That permits you to start seeing things happening in real time. Based on that, the fault detection or the next level of saying, my demand appears to be going up, it may be going to trigger a new peak charge that's going to haunt me for the next 12 months. You can identify things like that on the utility meters. Looking internally, you can detect faults in your own systems. Are the differentials in air pressures in your system indicating filters need to be cleaned and are interfering with efficiency? Are occupancy sensors telling you that this year your tenants are not in their spaces in the same hours they were before? All of these things that change over time lead to faults that can be defined and tracked. And then ultimately those faults are responded to either by a staff of talented engineers who are managing your buildings, or it can be through some sort of an AI system that interprets all this data coming in from meters, occupancy sensors, various devices installed in your buildings, and starts making those decisions and adjusting your building operations almost on an instantaneous basis to maximize efficiency and maintain tenant comfort. So the fault detection, beyond that, we call it active energy efficiency as Yardi's AI product that we want to dig into just a little bit deeper. We started with this in one of our buildings, an office building in California. We set a goal 5 years ago of reducing our energy use and greenhouse gas by 50%. And through use of these systems in our office building with a couple hundred employees and about 70,000 square feet or so, smaller building, we've been successful in reducing energy consumption and greenhouse gas by 60% in 5 years, all while maintaining comfort for everyone in the building. An interesting piece of that is we also, in spite of 5 years worth of rate increases, we reduced our energy costs by over 50%. So definitely worth investigating. We started with ourselves to prove the technology worked. Now let's talk about how this works, how we leverage this in buildings. And I'm going to pick 3 buildings we've worked on, East, West, and Central U.S. as examples. First building is an example of where we installed this AI technology to help manage the building. The technology, in this case, it's an 800,000 square foot building, and before we installed, it had received a BOMA 360 designation, so it was an efficient building. The result over time was a 1.1 kilowatt hour annual reduction in energy use. That translated to about $150,000 a year. And this client is of note because they have a very robust system for tracking client call or tenant calls on comfort. It's too hot, too cold, too drafty. And they documented a significant reduction in comfort calls. At the same time, they reduced their energy use by 1.1 million kilowatt hours annually. And that's starting with the BOMA 360 baseline. So a great building to begin with, one that Yardi systems through AI were able to adjust and improve. I want to go to another example, middle of the country, Chicago. Have a mixed-use building in Chicago, about 1.5 million square feet. It was LEED Platinum when AI technology was applied here. As a result, we were able to document a $285,000 per year annual savings in electrical costs. That's a 1.2-year payback. So for people doing the math on your side, that's about a $350,000 investment in the systems. Customers also shared with us it's about a $1.1 million cumulative impact to cash flow over a 5-year window. Think about that. Think about the other costs that Dan referred to with fees and fines, things coming out of energy use in buildings. And think about how these programs and projected cash flows can impact net present value of buildings. If your portfolio is one where you frequently acquire or divest buildings, the future cost of these energy efficiency projects are not limited to just the project, but also to the impact they're going to have on things like Local Law 97 fines that are going to come into the future here very soon. Keep that in mind. The last example I wanted to share today, real quickly, this one's in Washington, D.C., and it's one of my favorite stories to tell. 470,000 square foot office building. We installed our systems there, and a peek behind the curtain, we like to have a good baseline ourselves through benchmarking the historical energy use, be it in Energy Star or any system. We might like to know, how has a building been operating in the past? So starting with that as a baseline, we're very interested in the future utility bills as they come in after the AI solutions, the active energy efficiency goes into place on the building. When this building went up and started running, we were anxiously awaiting to see the results in the energy bills, and the utility bill didn't show up the next month. So part of what we do is call the utility and go, hey, where's my bill? And their customer service people couldn't tell us where the bill was. They said, it seems to be delayed in the system. We finally got a call back from engineers at the utility company, at the electric company, and they said, we have frozen the bill because we need to come out and investigate. We believe our meters are broken because all the energy use suddenly dropped 10% in the building. So we enjoy that story, obviously, because we were anticipating a cost savings. It was validated ultimately through the utility company, and customer, the owner of the building, remains very happy. The results were as anticipated in this case. So anyway, those are 3 quick studies. Before I wrap up, a couple of summary points. Back to what Dan said, it's all about the data. You must have quality data, whether you come up with effective technologies to read and scrape data from utility bills, whether you tap the meters directly from sub-meters inside or utility vendors, or whether you use some other way to collect your data. Data is where it starts. The more current the data, the more proactive you can be to minimize your cost and to reduce your greenhouse gas and overall reduce energy consumption. So utility bills are kind of the starting point, but that's history. Tapping local real-time meters gives you what's happening right now. Building that out with automating your faults to know what to go look at when something's happening, and ultimately maybe some sort of an AI to help manage your buildings is where hopefully a lot of people will go. As one of the early preliminary questions was size, what's the threshold? We see around 200,000 square feet is a building that generally can benefit from this type of really strong technology and the investment. However, we proved in our own office building that buildings less than 100,000 square feet can see paybacks in under 1 year from effective energy conservation measures. So it's always worth an investigation. Last point, and the thing I want to leave people with is that the technology Yardi provide to these 3 buildings and others across North America is not a building management system, but an overlay that integrates with existing building management systems. So it doesn't require a new or replacement to the BMS. In fact, our system is BMS agnostic. It doesn't care whose management system is installed. And if your engineers are challenged by having multiple building management systems they have to log in and out of, the Yardi solution does pull that into one dashboard. So it's been helpful for clients with desperate portfolios as far as BMS goes. So that's it. I look forward to answering questions in the Q&A. At this point, I am going to hand off back to Stacy and let her wrap up some things for you and move on to more details on our presentation today.
Thank you to both Randy and Dan for sharing your projects and also your tips. I think those are very helpful, and we've already received a handful of questions in the chat box. So before we move into the Q&A session, I just wanted to cover a couple of reminders on the program update side. The first is about ENERGY STAR certification for this year in light of COVID-19. So we sent out a mass email a couple weeks ago now. So most properties are now eligible to apply for certification using energy data through July 31st, 2020. You do need to update a couple use details though, so be sure to do that if you're applying for certification. And the full details are on our website, which is linked at the bottom here, energystar.gov/COVID updates. And then next, the certification deadline for this year is in February of 2021. So we are giving you some extra time, and that is because our next round of guidance on certification will be issued in mid-November. But if you're seeing your properties and portfolio manager are eligible to apply now, if that little button is popping up for you that you're eligible, we definitely encourage you to apply as soon as you can and to start working on those applications. So that's it for certification. But next time, and all of us here at ENERGY STAR are very excited about tenant space, this new program in recognition, which is launching next week on Tuesday. So we just had a webinar and this week introducing the recognition, and this is now will be available for offices starting on Tuesday. So if you have any questions on this, we do have a specific web page which we can send out in the chat box. It's energystar.gov/tenant recognition. So we're looking forward to working with many of you in that new recognition.